Good afternoon, Dr. Xavier and fellow students. Today I'll be presenting the potential inhibitory activity of Tanshinone I against 6LU7. 6LU7 is the crystal structure of the main protease of COVID-19. The main protease M-Pro plays a crucial role in the processing of COVID's replicase for proliferation by cleaving polyprotein in a process known as proteolysis. This main protease is the main target of Pfizer's latest oral antiviral candidate, Paxlovid, being able to inhibit proteolysis and prevent proliferation of the COVID virus, resulting in a claimed reduced risk of death and hospitalization by 89%. Being able to discover new or existing compounds against COVID-19's main protease could serve as a potential drug candidate against COVID-19 in the future. A database of compounds with associated bioactivity to 6LU7 was obtained and used to train a train test split and a prediction set to determine the potential bioactivity of a traditional Chinese medicine monomer library HYL065 against 6LU7. The top 5 compounds based on their activity value from the prediction set became the candidates for molecular docking. These were my 5 compounds obtained from machine learning, with the highest being HYN1996. Molecular docking was achieved by Pyrex's VinaWizard to determine the preferred orientation and binding affinity of our compounds with 6LU7. The compound with the most binding affinity would be the compound for molecular dynamics, which would be HYN0472, gerinin. Is how it would have gone if it were able to undergo molecular dynamics. If you notice, the title of my presentation was Tanshinone I and 6LU7 and not gerinin and 6LU7. All 4 out of 5 of the compounds were unable to run in NAMD despite hours of messing around with the force field and mol2 files, trying to get the parameters for a sequence of atoms that was missing, except for HYN0134. Also known as Tanshinone I, the compound with the least binding affinity. Continuing with Tanshinone I as our ligand, a total of 300 frames was produced in molecular dynamics, 240 frames in equilibration, and 60 frames in production. Seen in red is our ligand HYN0134 and our protein 6LU7 in blue. We can see that the ligand goes through tremendous changes throughout equilibration and production. Let's take a closer look at our protein. With a clear and distinct view, we can see that our protein enters production, it jumps RMSD and fluctuates slightly at a low RMSD, but our ligand continues to change drastically. Let's visualize what's actually happening to our complex in the system. Let's take a look. We can see that our ligand, even throughout equilibration, did not like its position and continued to change its orientation and spin around. By the end of production, it had moved to an entirely new position near the protein, nowhere near the predicted molecular docking site. LigPlot Plus was used to generate protein-ligand interactions. Analyzing the protein-ligand interaction, we can see that initially it was able to form a hydrogen bond with the glutamine, but by the end of molecular dynamics, no interactions could be found, with the only similarity is a far-off, irrelevant phenylalanine. Our machine learning algorithm and molecular docking had shown Tanshinone I as a promising candidate, but after molecular dynamics simulation, the RMSD observation and protein-ligand interaction had demonstrated Tanshinone I's inability to successfully bind to the 6LU7 protein to conform the necessary changes in its structure. Thank you.